But before we start writing our own models, let's have a look at what is the structure and the elements that we're going to see in the DBT models. So if you had a look already at the started project, you may have noticed that the models have a lot of curly brackets. That's because in the SQL files where we're going to write the select statement to transform our data, we're also going to be able to write in Xinxia. Xinxia is a Pythonic language that you're going to identify because it's going to be between two curly brackets or a curly bracket and a percentage. So this is a Xinxia block. It starts with this two curly brackets, ends with the other two curly brackets. Inside the Xinxia, we could use something like functions that are called macros that are going to help us later on generate the full code when it compiles. So at the beginning of a model, we're normally going to use the config macro. This macro, along with the parameters that we're going to define here, it's going to add the DDL or the DML to the model that we're writing. So here, for example, we see that we are only using one parameter, which is materialize equal table. This is called the materialization strategy. By default, DBT provides 4 materialization strategies, but you could create your own if you're an advanced user. The most common ones and simpler as well will be the table and the view, because this is just what it's called. A table, it's going to drop the table if it already exists in our data warehouse, and it's going to create the table in the schema that we're working with. So remember that I said that we're going to have a development schema and a production one. So it's going to translate to the schema that we're going to work with, and it's going to create a table with the name of my model. So here, for example, we see that the compile code, it's going to look something like this. Create table, my schema, my model as, and the query that we had. And this is going to run in our data warehouse, and it's going to create such table. The view is exactly the same, but here it would be something like create or alter view with my schema, my model. Then we're going to have incremental, which is essentially a table. So in the data warehouse, we're going to find a table, but this materialization strategy is going to allow us to run our model incrementally. And this is very useful for data that doesn't really change every day. So we could only run our model and transform and insert in our table only the latest data. And ephemeral is something similar to having a CTE separated in another file that we could embed. So it's a derived model. I said that the models are just a select, essentially. So the transformation, the business logic, we're going to translate it to a select statement. But a select statement has a from clause. What can we use in the from clause when we're developing a model from DBT? So first of all, we already know that we want to use the sources that we loaded from the green and yellow trip data. For those, we're going to be able to use a macro that's called source. And what it's going to allow us to do this, we're going to be able to define such sources in a YAML file with all of the configuration. So here we could set the database, which for BigQuery would be dataset, and a schema. And then under one schema database, we could define as many tables as we want. So we're going to define the source once, and we can define as many sources as we want. And then we're going to call it from our models. And this, it's going to translate. So here, when we say source, station yellow trip data, it's actually going to translate to production dot trip data all dot yellow trip data. This macro is going to basically resolve the name for us with the right schema, and it's going to also build the dependencies automatically. We're going to see that at the end when we see the documentation. Another good benefit of declaring sources with DBT is that we could define a source freshness, and we could then run that as well and validate the freshness of our sources. So something like here, we can see that the freshness is set to 6 hours. So then we could run a source freshness check and see if the source is fresh. So it has data from the past 6 hours. Another thing that we could use as well to load data to our data warehouse is CSV files. So this in DBT is called seeds. It's nothing more than a copy command. So anything that you could do in a database, you could just upload a CSV. The benefit here is that we're going to have those CSV files in our repository. So we have the benefit of the version control. We're going to run it with a special command that's going to be dbt seed, and then we can select one specific file, or we can just run every seed file that's in our seed folder. This is, of course, recommended for data that doesn't change frequently. Anything that is a lot of data or that changes very frequently, it's recommended that you set up a pipeline. And here we can see an example of how the CSV would look like. So a common CSV separated with commas. And this is how we could call it from a DBT model. We're going to see that there's also here a macro that's called ref. And here the name of my CSV file. And let's go into detail of the ref. So this is a macro that's going to allow us to reference underlying tables and views that we had in the data warehouse. I said that with the source, what it's going to do when we run dbt seed is going to create a table similar to what it does with the copy command, right? So imagine that every model will also do something similar. We'll create either a table or a view in our data warehouse. We can call those tables or views that were created from either dbt models or dbt seeds using the ref macro. See that here I only add one name. I don't add here the schema, the database, or anything else. This is because the ref is going to resolve that for us, which means that if I'm developing in my environment, so in my sandbox, it's going to translate to DBT Victoria Mola. We can see here how it looks like compile code. It added my database name, my schema, and then the table name, which is this one. If I'm running this in production, this will translate it to my production schema as well, not to DBT Victoria Mola. If I have a coworker that it's running this in their development schema, this one will translate to their schema. This is also going to build the dependencies automatically for us. So this is a very good benefit because it encapsulates the logic. So it encapsulates where this data is actually hosted, and we run the exact same code no matter which environment we're using. Let's now go back to the editor and start creating our first model. So under the models folder, I'm actually going to create other two folders to store our models. The first one will be called station, and in this one, we're going to start creating the raw models. So taking that raw data in views and apply some typecasting maybe, or some renaming of the fields. And a second folder that we're going to call core. And in this one, we're going to create the models that we're going to expose at the end to the BI tool or our stakeholders. So under station, I'm going to create a first model. So a new file. We're going to call this station green_trip data.sql. And in here, we can already copy the config block. We're going to define a view, not a table, because we want these station models to all be views, so we don't have the need to refresh them constantly, but we would still have the latest data that has been loaded. And in here, what we want to do is basically something like a select start from trip data all dot green_trip data. So I can, of course, write my model this way, but we want to do it using the source macro because that is going to resolve the correct schema for us. And it's also going to build the dependencies. So it will generate the lineage automatically for us. To do so, we have to create the schema YML here. And we're going to define the source. The first thing that we're going to do is at the beginning, we can also see it in the example. They have a version defined. And then we're going to do sources. And we're going to define a name for our source. This is just a name. It doesn't mean that it has to be the exact same name that we have in our database. So here we could define, for example, if we have several sources that we pick up data from, then we could just name those sources with a group. So the origin, for example. In our case, we're going to call this a station. And here we're going to define a database and a schema. So the database, in the case of other data warehouses that we could use, it's very clear. In the case of BigQuery, it's actually a data set. So I'm going to go to trips data all, and then I just query. And this is the data set, and this is going to be the schema. So I'm going to copy that from here, paste it here, and then trips data all. And then now that I have defined a source, so now that I have defined basically the database and the schema, I can define as many tables as I want that I could have under that source. I'll just put tables and then name and just add the names of those tables that I want to use as sources for my models. And other thing that said that it's a good thing about sources, using sources in DBT, is that we could also define a freshness. So to each one of these tables or to the source in general, I could define a field that I know that it's the one that's being used to load that data from the sources to extract and load it. And I could define a threshold for that freshness. So let's say I know that a certain table, so I know that I receive green trip data every hour. So then I can define a threshold of 3 hours. That way, if I check the source freshness of this green trip data source, then it would go and check in the loading field, and it will count the date difference, and it will make sure that there's no data that it's older. So the latest data is not older than this threshold of 3 hours that I've defined. Right now, we're not going to do it. So just let's save this and let's go back to our station model. So here, then what we can do is use, as we said before, and we saw in the slides, we're going to use source, the name, and the name of the table. Note also that this name, as it doesn't have to do anything with the data warehouse, I could, of course, use the same as the schema or anything else. But as it doesn't really have the same name, it also encapsulates a little bit where is the location of my source. I don't need to do that to know that. I just go to the schema, which means as well that if we want to, for example, run the same project in our Postgres database, then after we change the connection, we can simply just change here the database if we have a different name, and then it will be migrated for every model that uses the sources. I don't have to go to each one of those models. Let's put a limit here because we know that we have a lot of data, and we want this to be fast. You can see here already that there's a lineage that it was created for me. Everything that it's green, it's going to be a source. And then on top of it, we have our model. Let's now run this model from here. So here there are two things I could do. I could do dbt run -m and then select the model that I want to run, or I could just do dbt run and it would run every model that I have. And that would include also the ones from the example. So let's do that one. And what I'm going to see here is that at the end, it's going to show me how many models were built, how many failed, and how many were skipped. Because if a model is built on top of another model that failed, then as DBT knows the dependencies, it's going to fail. So ours went just fine. And then what happened here is that something with the schema was not well defined, so then it failed. And since my second model depends on my first one, then it was a skip. So we're not going to care about those models because we're going to delete them anyways. I'll just delete those folders and we can continue with the station and green trip data. What I'm going to do now is, instead of using a star here, I want to define the fields. And the reason for that is because I want to make sure that I use the field names that are the same for the green and the yellow trip data, and that will require some renaming. So I'm just copying here and pasting the code from the repository. For example, the pickup and the drop-off time, I changed them to pickup and drop-off daytime instead of lpip and in yellow it was tpip. So I would keep the same, and I also apply some typecasting. At the end, I'll just keep the source here and then a limit temp. And I can save that, and I can simply just, I can do -m, I can do minus select, or I can do -s. So all of these are equivalent for DBT. So let's run it. And let's now go to all went fine. And now let's go to BigQuery and let's go to, here is the station green trip data that we just created. And this is actually from a previous run that I had made, not from this one that I already had them created, but you should have them if in your case it went all right. Okay, so let's go back to the slides and let's learn about macros. Macros are similar to functions that we're going to write with Xinxia. What we can do, so DBT has already a lot of macros that already include that we've seen, like the ref, like the source, like the config, but we can define our own. These macros are going to return code, which is the main difference with, let's say, an UDF. Because in here, we define something similar to a function in the sense that we're going to use the macro statement, and then we're going to define a name, and then we're going to define parameters within brackets. So very similar to how we would define a function, for example, in Python, if we think about the general structure. But this is not going to return a result. It's going to return a code. So let's say we were to have two parameters, A and B, and we want to concat them. So normally in a function, it would return the result of the concatenation between A and B. In the case of a macro, it would return the code to concatenate A and B. This is going to be very helpful if we want to, for example, maintain the same type of transformations in several models, and then we only write it once, so the same benefits as we have for a function. How do we define it? We create a separate file under the macros folder, and we're going to use a combination of Xinxia and SQL. So here we see the other ways that we could use Xinxia as well, one with the curly brackets and the hashtag. This Xinxia block is a comment block, and this one with the percentage, so in between here and here, this is going to mean that we're going to execute something, basically. So the macro is going to define, it's going to mean that we're defining a macro, and here the name, and here the parameters. Between the macro and the end macro, we're going to define the code that we want the macro to return. So if you see, this is simply SQL. And when we have the two curly brackets, we are indicating that this is the value that will translate to. So this will translate to the value that we receive when we call the macro. So this is the definition. This is how we're going to use the macro. So imagine this is our model, and then here in between curly brackets, the same way that we did with the ref, with the source, with the config, we're going to call the name of the macro, and we're going to send the parameter. So note that here payment type and payment type is the same, but this could have been anything different, and it would just translate the case. This is how it's going to compile the code of the macro. Where I had the macro calling, then now I have a case statement. And where I had the variable, now I have the payment type that I pass on when I call the macro. Imagine that we have several sources and we want all of them have the same description for the payment type. But all of the sources, they could have, instead of payment type as a field, they could be sending this number in a field called payment ID, payment description, or something like that. And we could just call them with all of these different names here, and it would only translate the case here. So now we're going to use this macro as our own. We're going to go to the macros folder. You're going to see that you already have the git kit probably because this was created entirely empty. And we're going to call our macro get payment type description. And you can add this SQL here. So note also as well that I'm using the same name, the get payment type description, but you could just have a SQL file that's called something like macros and then define a load of macros inside. As we already saw the code in the other part of the presentation, then I'm just going to copy paste it. This is a comment. This is not going to be added in the compilation or anything. This is very useful to explain the code, the macro, document it. And we're going to save this. And now we're going to go to the station trip data and we're going to call the macro. So we call it the same way as we do with the others that we've seen so far. So we just put here get payment type description, and in between we're going to send the name of the field that we want to use for the case statement. This is just going to paste a case statement here, which means that I still need to put a name to this field. So let's call this payment type description. And now we're going to run this again. And we're going to see how it looks, the compile code as well. So this already went fine. And you're going to see that there's this target folder that we saw that was in the git ignore by default. This is because here you'll have all of the compile code from the models that it's generated when you do a DBT run. So under the same structure that we have, so if we open compile, then we go to Taxi Rides New York, models, the station. Note that I, for example, don't have the core still here because I haven't run anything under core. So under station, I can go and find the station green trip data. And look, this is just the select code that was compiled. And let's go to the part where the macro is supposed to be. Here we can see how it added the case statement. And we can actually also see how it translated to the right schema on the source as well, something that we've done before. Okay, so far we've done a macro, we created a model, we've run the macro, but it's also very useful to know that we could also use macros from other projects in our projects. And the way to do that is using packages. So like any libraries in other programming languages, in DBT you can use packages. So these are basically DBT projects, the standalone DBT projects that have models and macros of their own. They could also have tests that you could import to your own project. By adding this package, then you're going to be able to use the models and the macros of your own. And the simple way to do it is you create a package YML file. in the main directory of your project, and you define the packages that you want to import. So for this project, we're just going to use one from DBT Labs, which is called DBT Utils. And you could also go to the DBT package hub and find a lot of useful packages that may have different things between macros or models, or you could also look in GitHub as well. And this is how we're going to call the macros from the package. We're going to do something similar, so in between the Xinxia, two curly brackets, but the difference is that similar to how we would do with a library in Python, we just put dbt underscore utils dot surrogate key, which is the name of the macro, and then in the middle, we're going to put the parameters. So this macro at the end is going to apply the MD5 function to whatever we put in this list of parameters. So let's do that as well. Under identifiers, I want to have, let's first create the package. New file. I'm going to copy paste this. So know that here you define it similar to that the sources, and then you put package, the name, the version you want to import, and you can here define as many packages as you want. So how to install these packages? We're going to run dbt dapps. And this is going to download all of the dependencies that are needed to run this project, which means in this case, one package. You can run this also on your terminal, and if you already know that there's a packages YML in the project, so for example, if you want to run the project directly from the repo, the clone repo with the end project, then you should first run dbt dapps to be able to run your models. And we actually can see here on the dbt packages that it created a dbt utils folder that it has all of the code. So you can go through this and you can actually see the code for those macros that dbt packages is providing. Let's go back to a stage. This is the compa code. Let's close this. Let's go back to the model and let's then add the identifier. So I said that we would call it as a Xinxia function, and we're going to call this field trip ID. And here what we're going to do is dbt underscore utils dot surrogate key. We're going to have the parameters inside, and the parameters are basically a list. We're going to send two things that we're going to use to create a unique key for this model. And the pickup data. I'm going to use the original name and not the one that I renamed it, because by the time I'm using it here, it's not renamed yet. So let's run this. And we're going to check the compa code in a bit. Let's go back to the compa code. Let's go to a station and let's see how it translates now to hex MD5, and then it does a coalesces to make sure that we're not adding null values, and then it does a concatenation between the two. And then at the end, we're having a unique identifier for our model. Okay, so now we have a very complete model already. Let's see how we can also add something extra, which are variables. So variables is the same concept as any other programming language, and they're very useful to define values that we could use across the project. So we're going to use a macro, same as everything else, that it's going to allow us to get that data from the variables and translate it basically during the compilation time. So there are two ways that we can define the variables. One would be in the project YML file. And this would be something similar to what is a global variable, for example. So here is how we would define it in the project YML. And I could then just call with this var macro the payment type values, and it would return this list. Or I could just define it in the terminal. And by that, what I'm going to do is imagine that I have this variable, for example, and what I'm saying is I created in the Xinxia an execution statement that it's an if. Note that here it's very similar also if and if. And we're going to call the var macro. And here is defining the variable in a certain way is test run. And I'm also providing a default value for this variable, which means that if I run the model by dbt build -m and the name of my model, without this part, is test run is going to be taking the value of true during the compilation. But if I do --var is the test run false, then it's going to take the value of false. This is how I can alter the value during the run of my model. So let's add that part to our model. And this is going to allow us to run locally the same model, either with the limit 10 or without the limit 10. Here, I'm also going to add where vendor equals is not null, and we can run our model. Since I'm not defining any function, then I should see under the compile code that it's going to be adding, it's going to take the default value, which is true, which is then going to mean that it's going to add a limit 10. So if I go again to the target staging, I'm going to see the limit 10. But if instead I do the exact same thing, but I do --var and in between, then we're going to see how the compilation is going to change. Let's close this and here it was taking the old version, but here we can already see that where vendor ID is not null, and it left the comment, but it didn't add the limit 10 because I indicated in the terminal that this is not a test run, so it changed the value. Okay, cool. So we have already our first staging schema. So we're going to do something very similar with the yellow trip data. I'm just going to copy paste it, and you can do the same. Same as before, I'm just going here and I'm creating a new file. I'm going to take the same name, but I'm going to change it to yellow. I'm going to copy paste the code. It's very, very similar to the green trip data because at the end the schemas are also quite similar. There should be only smaller changes, like in this two fields that are are called different, but at the end they're going to be called the same. And some other fields that I define as default values. Plus, it's going to select from the source that we had already defined in our schema YML. So if you remember, here's the name of our source, and here it was the table. And we're going to have the same limit. So this is very useful when you're running in development because many times if you don't if you work with big tables, you don't want to pick the whole amount of tables because you're just testing, and it will also speed up your running. And let's run it without the limit anyways. I'm going to do dbt run because now I have two models and I would like to run both. And Let's see, it ran both of my models, and if I go to my BigQuery, I should be able to see both of them under here. Looks like it needs to refresh. There they are, both of my models. We are now going to start working with DBT seeds. As I said before, DBT seeds are CSV files that we can have in our repository and then run and use as tables with the REST macro. These DBT seeds are meant to be used for smaller files that have some data that will not change that often. So for example, the taxi zone lookup, it's a good example. Unfortunately, we still don't have a feature to upload those files in the UI. And here we're going to have different choices. If you're developing locally, you can simply just copy paste the file that you downloaded under the seeds folder. If we're working with the cloud, then this at the end is just a repository. So we could commit, push, then from our repo, we could just upload here the file under the seeds folder, and by pulling, we would have it here. Or what we're going to do right now is just create the file. So I'm going to create the taxi zone lookup CSV, and then I'm going to go to my file and I'm going to paste it. What I need to do now is run DBT seed here, and what it's going to do, it's going to create this table for me in the database, and it's going to define for each one of these fields, so for location ID, borough, zone, and service zone, the data type that it corresponds, that the same way that it would happen when we do a copy. So let's see, here already run correctly, it started 265. So we could actually go to DBT project and imagine that we don't really want to use those same data types that they're defining for us. So we could create here an entry for the seeds for our project, taxi rides _ New York. And we could put our seed, so taxi zone lookup. We could enter column types, and this is going to mean that we are going to define some of the column types or every column type that we want, and it's going to first take this column types, and then for the ones that we don't define, it's going to take the ones by default. So if we save this, then we can run it again and we'll see that it will create the table. Let's say that I want to actually change something in my table. So instead of having EWR here, I want to put an N. This would change a value. And what happens with DBT seed is actually it's going to run and it's going to append things to this table that we had already created. So we could run a DBT seed -- full refresh. And this is going to enforce that it drops the table and it's going to recreate it with this value that we just created. Let's see how it goes. And we can see how it created our seed and inserted 265. So now that we have this, we can see how we can create a model based on this seed. So let's go to the core folder and we're going to create the model called DeemZones. So new file, DeemZones.sql. And here, what we're going to do is just first define the config. I'm going to take it from here. I actually want this to be a table. Ideally, we would want to have everything in the core that it's a table, because our models are going to be exposed to our BI tools, so it's going to be more efficient if we have tables, and we can run them under schedules. And we're going to select everything from the taxi zone lookup. And I'm going to copy paste those things. And what I did as well is I added at the very end, there was a difference in the service zone, and then the green one was actually being called Bordeaux. And I didn't want that. I wanted to have green or yellow. You can check that here actually, Bordeaux zone, or yellow zone. And so I just added every place. And what we can do here is do the from, and we're going to see that we can use a ref, as we saw in the slides originally, where we would put the taxi underscore zone underscore lookup, and it would create a model that it would depend on my seed. You can see already here that it's also green. The seed is similar to the sources. It's a different type of green, but still. But it has a different icon here, so you can actually see that it's coming from this folder, the seeds folder. And it creates my model on top of it. So it already generated the lineage for me. I can run this model, but what I'm going to do is actually create a different model now. I'm going to create the fact trips. In the fact trips, mainly what I want to show is that we can take both models, the station green trip data and the station yellow data now, and it's going to generate a lineage for both of them for us. So what we're going to do is I'm going to just copy paste the same code from the repository because it's very long and we already know SQL and the concepts here. But let's review what's going on. So I'm selecting everything from my station green trip data. I'm just adding another field to later be able to identify which service type does it come from. And for this, it's very important, of course, that we kept the same schema for green and yellow trip data. This is why we renamed them to have the same file column names, and we also added some default in the yellow ones. And then we're just selecting, and we're going to take from the zones the same way that we're going to take from the other tables, the models. And then we're just going to union them. We did an inner join on the pickup and the drop-off zone to only keep the zones that have an entry in them zones, and have in mind that I'm also taking away the zones that are unknown. So let's now save this and let's see how the lineage looks like. So we have the 3 sources in green. 2 of them are the actual sources that we loaded the data on, and the other one is the DBTC. Each one of those has a model, and then we have a fact model on top. So once we run dbt run, everything here will run, except the seed. The reason for that is because dbt run will only run the models. So if you see, we only have dim zones here, station, green trip data, yellow, and fact trips. But if we wanted to also do the seed, then we could use dbt build, and this is also going to run seeds and test that we haven't seen yet, but it will basically build everything that we would have. If you see here, it also includes taxi zone lookup. Something also very interesting that we could see is that we could do, for example, let's do select fact trips. And if we do select fact trips, if we run this as it is, it would only run this model fact trips. But if we do the plus, it will run everything that fact trips needs. And this is everything that we're going to see in the lineage. So we saw already that fact trips is dependent on the dim table, the geostation, and the taxi zone lookup. So if you see all of this appear here, and then at the very end, it runs fact trips because dbt already knows the dependencies. So then it resolves that for us, and it runs the models in the order that they need to be according to those dependencies.